Excuse me. Hello, everybody. Excuse me for my slight lateness here. Welcome to the stream. Happy Monday. Let me go pick my folders here. It's going to be multiple inheritance. Okay. Going to verify. Looks like my microphone's working okay. This should be much bigger. As well as we'll be connecting into MOBA. Today we're going to continue our inheritance discussion. Last class we started inheritance and composition, and we talked a little bit about some of these things here in the notes. Today I'll be continuing off of these notes. Notice that I did clean them up quite a bit compared to whatever we were discussing in the last video. And so here we've got our main subjects. Recall that composition has a relationship and inheritance is a relationship. Excuse me. And then I reviewed what public, private, and we learned what protected is, right? Which means that this protected member would be accessible to the class and the derived classes. And I like to say it as inherited private. And then we talked about these things called member access specifiers, which are the same as these, but for inheritance. And so here's our syntax, right, to inherit from a class. And if we don't specify anything, it's going to default to private, meaning that if this is gone, then it will default to private. We kind of experienced that. I had a little bit of an error. Got to fix my title here. Update that. Okay. We talked about this kind of super private thing, right? Which really, it's kind of an interesting concept, right? Because when we're talking about private members, it's true that these members are only accessible to a class, right? It's only accessible to the class we're talking about. And so, in fact, if we derive any classes from, Class A, from Class A to Class B is not going to have access to these private members, even though Class B is an instance of Class A, right? As we said, a cat is a mammal. So it's kind of odd to think about that Class B wouldn't have access to things that are a part of itself. You know what I mean? A part of its DNA. So that's what the super private thing is, right? When a private member inherits into a derived object, the derived object has this member, but we cannot access it. And so then we discussed about the three types of ways that we can inherit from objects. Public, everything just stays the same, right? Except for the private members become super private. Private members, everything becomes private. And private members become super private. That's just the same for all of our inheritance methods. And then protected, public members become protected. The protected members stay protected, and then we've got the same super private thing going on here. And so then we kind of wrapped up here talking about some inheritance notes. And this is just a good review to spend the first 5 minutes of class talking about. Today we're going to cover an example of multiple inheritance. We're going to talk about what's bad about this. And then we also mentioned that classes can be derived from derived classes. All members of the base class are in the derived class. We know this. We know what a function override is. We know in a derived class we can add new members. We're going to have an example of that today. Remember that inheritance is one way. And then we started talking about the constructors. So we're going to get more into that today, in which a base class constructor is always called before the derived constructor. So day 2, I'm just going to kind of put these here, though I'll probably clean it up at the end of class and upload kind of some newly organized notes. But today is kind of day 2 inheritance. And there's a few things that we need to talk about. I think that's right. So before we move on with this, are there any questions about the assignment? I do know that I have office hours scheduled at least with someone after class. If you have some questions, you can come to office hours. Just know if I'm not sitting in this, if I'm not sitting in there, then I'm probably in a call with somebody. So just send me a message, to let me know that you're waiting for me. And I will get back to you. So let me just kind of pull up the Discord here real quick. See if I can zoom in here a little bit. Hello, Discord. Ooh, nice and... Yeah, this is kind of nice and big, right? So I just sit in here, right? If I'm not in here, just send me a message. I posted this thing about string find. So if you don't know how that's working, I gave that to you guys. I mentioned the thing about compiling these functions, right? Don't just try to compile the header files. You have to compile the CPP file. If you compile a header file, you'll get some errors that don't really make sense. And then I also mentioned this thing about how I did a little bit bad design on assignment 2, in which even if this database doesn't get read in, meaning that you press Q on the file or the file just doesn't get read, it will still call search, right? And hopefully the way you've implemented your functions, the size of the database will be 0 anyway. So when you call new search, it's just going to say 0 records found anyway. So it kind of makes sense. But just know that it's a little bit poor design on my part, and it's okay to just press Q twice. I'm not going to ding you guys for that. That was my fault. So it looks like chat's pretty quiet today, so we're going to go ahead and get started here with some code. I know we were doing this example last class with the engines and the trucks. We're just going to leave it at the engines, and today I've developed 2 new examples for us that I think are very interesting and will help us really see what's going on with this inheritance stuff. So we're going to kind of jump right into that. And since this is day 2, I'm just going to kind of copy this stuff down here. And we're going to start with this multiple inheritance thing. Just so you know that it can be done. Now, multiple inheritance means a class can inherit from multiple classes, right? So we'll talk about the syntax for that. Now, some languages, some programming languages, this will be kind of focused on in 326 when you take that course. Do not have this. It's very difficult to implement for a compiler, but C++ does. And it definitely has some issues. So we're going to talk about the ambiguity part of it today. And then we kind of talk about the implementation of things like this. And I'm kind of going to pull up an Excel file just to kind of put it in your mind. Just so you can think about it. It's not important. This thing here I'm about to show you will not be on the test by any means. So don't worry about it. But let's say we've got a class here. And I don't know, I guess we'll call it... Well, let's go ahead and do our example first. And then we'll come to that. So I can literally put them side by side. I think that's a great way to do this here. So we're just going to get started with our programming here then. Now, multiple inheritance is pretty difficult. Just to think about in general, And so I definitely have a bit of a silly example here, but we're going to go with it. Okay, so let's think that we're talking about families, right? You inherit from your parents, from your grandparents, and people before that. So I think that this is probably one of our better examples to start with. So let's imagine that we have a family class. Now, this family class is going to be very simple, okay? We're not going to do constructors, destructors, anything like that. We're just going to keep it in terms of inheritance. Let's see if I want this. Probably I want this to be protected. So every family, we're going to say, has a string origin. Now, I'm sure, as well as myself, that I come from all over the world. My family bloodline is from all over the world. So no one family has a string origin, but let's imagine that from the beginning of time, you just have one, right? So that's kind of what we're assuming here today. And we're going to make a constructor. And can anyone tell me or remind me of the syntax if I want to initialize this value in such a way that it happens before the body of the constructor executes, kind of how that constructor would look like. I know it's a bit of a... You don't have to type out the whole thing, but let's imagine I pass in a parameter string O. How would I initialize this variable? And then I'm going to do a little cout here. This is the family constructor. So here's the body of our constructor, right? And the only reason I'm bringing this up today is because we're going to focus on it more today, because it matters a little bit. But you can initialize this origin variable to be like this, right? Origin equals 0. Origin equals O. But if we want to do it before the body of the constructor executes, we're just going to... Yep, there we go. Nice job, Red Rosenrot. That's exactly what I mean. So I'm just putting in your mind, because this is going to come up today. We're going to put that colon right there, right next to the constructor. And up here, we're going to put origin, and we're going to initialize it to the value O. So that's exactly what's going on here. This happens in the body, and this happens before constructor body. So that's it for our class family. Pretty simple one, right? So now we're going to inherit. We're going to make two families here. We're going to take my family, and we're going to take a Lopez family. And so here we're going to have class Piotrowski to start. And this class is going to inherit publicly. So remember the syntax for that. I'm going to put my member access specifier right here. And it's going to inherit from the family class, because my Piotrowski is a family. And now this family has an origin, right? So there's actually nothing I'm going to add to this, because this protected variable from the family is going to come into this Piotrowski class, into this Piotrowski object. So I will have access to it. And so I'm going to call... let's make a default. I don't want to make a default. Well, yeah, let's do that. This would be the best time to do this anyway. Say in our base family constructor, this is going to be params. I do this a lot. I think you notice at this time. And then this one's just going to be the default. And we're going to initialize our variables, origin, to be just empty string in this case. Now, strings in general will be initialized to this already. But we're just kind of talking, we're reminding ourselves what's going on here with this initialization. So, I'm going to make this Piotrowski class. And this Piotrowski class is going to have a constructor. And guess what? Piotrowski is Polish. That's where that comes from. So we're just going to say that the origin gets initialized to Polish, right? Now, it doesn't like this. Let's see why. And I have an idea. It says that this is a non-static base member, so I guess that this value cannot be initialized from the inherited class because it's already being initialized in the other constructors. But what we can do is this, right? In fact, I can come in here and I can say origin is equal to Polish. And so we'll just do it this way for now. And we're gonna kind of see how our constructors execute. Now, there's one thing I'm going to do here. We're going to copy this guy. And then we're going to go execute some code and talk about what's going on. So that is our Petrowski class. So we're going to come in here and we're just going to remind ourselves what's going on. Recall from last class that, if I zoom in here a little better, where's the constructor? A base class constructor is always called before the derived constructor, right? So I'm going to say Petrowski person. And that's all I'm going to do. Can anyone take a guess? We have two constructors here, right? Can you tell me which one will be called before this one? I'm not saying that you should know it, by heart, but it's kind of obvious here, right? Or hopefully it will be. And while I'm loading this onto Bobby and I do my zoom in, I guess I didn't even log in, huh? I see we got an answer there in the chat. Let's see what you guys think. Yes, precisely. That's exactly correct. And so the default constructor will be called. That's exactly what will happen. So let's go ahead and just test that to show ourselves that we're speaking English here. We're speaking C++ rather. Where did I save this? I saved it here. It's going to come into here. We're going to clear this bad boy. We're going to find my favorite G++ statement. We're going to compile it. Yep. And when I run this, we will see, boom, default family constructor. I guess I zoom in here a little bit more. Zoom, zoom. So we see default family constructor is called first. And then we see that the default Petrowski constructor is called. Now, here's what I'll say. It makes more sense for us to call this constructor. And the reason is because look what I'm doing to this origin variable here, right? I'm calling the default. It's getting initialized. And then I'm like, hey, we'll just overwrite that. So the question is there a way to call this constructor from this constructor? So we're going to add this to the notes, and we'll come back to our multiple inheritance ambiguities in a bit. So we're going to say specifying a constructor for the base class to call. So we use this. It's called the inline method, and it's like the initializing thing. I guess I don't know what to call that. Like initializing var's for a class. So in the inline method, we're going to have some syntax here. And so what we have here is we're going to have the base class. Now this is the constructor. So we're going to have our base class. We're going to put our colon, which is what I was trying to remind you guys about. It's not going to be the base class. I'm sorry, everybody. It's the derived class. So the derived class, it's going to call the base class. And then whatever one that we want to call, we'll determine it with the parameters. And then we're going to have some body, right? Some code. Now let's see if you guys know your C++, because why couldn't I just do this? Once again, no judgment here for anyone who doesn't know, because we're all learning, but I would like some guesses. Let's say I just do this. Does anyone know what happens here? Because look, I'm calling a constructor. I'm calling a constructor from this constructor. And I have access to this constructor because it's public. But is this really doing what I think it's doing? I'll give you like a few more seconds because I'm guessing that you guys don't know, which is totally fine. But it's kind of confusing. So this is a constructor that we call, and it's kind of like the same thing as doing. We're getting some guesses here. I like them. I love them. Peter says it's the class. I do. Yeah. So I appreciate that. You're on the right track, Peter. Absolutely. It is the class in a way. And I like this infinite loop thought. But this is like saying this. This is like just declaring an object. It's just like declaring an object. So when we do this, we're going to see default constructor called for the Petrowski. And then let me make sure that we do this correctly because I want to show you. And then the Petrowski constructor is called. And you know what? We're even going to add a destructor to this family class real quick. Because I want to show you what happens. So this is just the destructor. Destructing, who knows? Doesn't matter. This class is not about the, or this example is not about the destructor yet. But we're actually going to see a destructor called before the end of this constructor. Because we are declaring an object in this scope here, in the scope between these two brackets. So as soon as we leave the constructor, this thing is going to destruct, and then we actually never set the origin parameter. And in fact, the origin for Petrowski will remain blank. So it's kind of confusing, but that's why we can't do that. Because the constructor is like declaring an object. That's the only time that we really call the constructor. So look at this. We call default family, default, right? Here's the default family. And then you see this print statement. And then we call this parameter constructor. And it says params family constructor. And then it says destructing, right? Because it gets to the end of the constructor. And then this is at the end of main, right? So let's go ahead and throw this out the window. And we'll come back to it in the next example, so don't even worry about it, that I deleted it. And we're going to call the family constructor the way that I said we would. So just recall, here's the syntax for that. Derived class, base class, and its parameters. Whoops. Why did I do that? And we're just going to pass Polish to it, right? Boom. Just like that. We're specifying which family constructor is called. So now we will drag this into Bobby, and we'll see that we'll no longer see this default constructor called. And in fact, it will be replaced with the parameter constructor. So you can see there that the very first constructor that was called is the parameter constructor. So we kind of overrided that or whatever. We said, hey, I don't want this default constructor. I want the other one. So that one was called before the body of the Petrowski constructor. So hopefully that makes sense. Let me just make sure the notes are good. Specifying a constructor for the base class to call. Inline method, right. And there it is. So that's good. We'll save that. And now we'll finally move on here to our multiple inheritance. So now I'm going to have a Lopez family here. And these guys are Spanish. Right, and so this is just another family that's like Petrowski. This is the Lopez family instead. And now, let's say these two families get together and they make a new class. So that new class is going to be, I'm going to put some, I'm not really doing many comments here. I want to kind of just separate things so it's easy to see. I always like doing that. So this is our family class. So our Petrowski class here. Now, obviously, we can see that, right? But these green lines really make it easy for me to tell where the different code is. There's our Lopez class. And then finally, we're going to make a Lopez Petrowski class. So these two families got together, and they made another class. It's going to be the, whoops. It's going to be the Lopez Petrowski class. Now, what is the syntax for multiple inheritance? Let's put that in our notes. So it's going to be class, derived class, colon, and then we're going to say our member access specifier, right? Or a member, let's see what I called it. Will make sense. Sometimes I really don't know what's going through my head, guys. And you're watching from the other side. This should be MAS, not MSP. Member specifier public. I don't know what I was getting at. That's a mass. That's not an MSP. I can't believe I even missed that all the way up till now. All right, so now that we've corrected that, I'll make sure that we correct that. It's going to be mass, and this is going to be base class 1. I guess we'll call it base class A. And then we just add commas. MAS base class B. And in here, we're going to have our class code, right? So derived class, and then we got the same colon, and then we're just going to list them with commas right out the right side. Just like that. So if we're going to do this Lopez Petrowski class, we're going to inherit. Let's go ahead and do a public inheritance. It's my favorite. From the Lopez class, and a public inheritance from the Petrowski class. Just like that. Let's see if I zoom out just a little bit here. I think you guys can still read that okay. And now we kind of got this issue here. Let's bring out my favorite program, Microsoft Paint. It's going to act as our whiteboard. And you'll see this diagram in your book. So whenever we talk about this, this is what you'll see. So this is our family class here. And what it does is it makes a bit of a diamond. And I didn't do this properly, but I'm not the most efficient person in the world anyway. So this is going to I'm not going to type out my full last name. This should be Pout class. This is going to be Lopez here. And now we've got the Lopez Pout class, right? So in fact, I'm going to change my colors up here. Piotrowski is inheriting from family. And Lopez is also inheriting from family. And now, Lopez Pout is inheriting from Petrowski and from Lopez. So we make a multiple inheritance diamond here. I guess I'll put this in like kind of a blue color or something. And I'll upload this little diagram. Is it diamond? I think that's right. Now this is a huge issue because there's some ambiguity here, right? Because in this class up here, I'm going to make this a little bit smaller. I think you guys can see this okay. We've got an origin, right? going to copy this. And now these two classes inherited from this class, right? So this class here has an origin. I can't grab it, so we'll just put it here. And then this Lopez class also has an origin. So which origin does this class get? Because it's inheriting from both. This object has an origin and this object has an origin. So now this class has two origins, which makes sense in real life, right? But what are we talking about, you know, when we get here, and how do we deal with that kind of stuff? The same idea goes for what if these two functions had the same function in it? You know, this said print origin and this said print origin, and then we call print origin from this class. Which one are we talking about? So we kind of have to deal with that. And so I'll show you the compiler error, and then we're going to move on from this example. So I'm going to have a private member here eventually. But for now, we're just going to make the constructor. Ooh. And I'm going to show you guys. I'm sorry, I think you guys saw my grading files there. So that goes there. Oh, and let me just bring this up for those of you who are here and have not done it. If you saw your grades, you'll see that I just mentioned the function that there was an issue with. Now, that's not entirely descriptive. I ask you guys to contact me, right, if you can't figure it out yourself, and I will first make a document for you. If it's 11 p.m. at night, that document might be kind of sleepy and not all so much English, in which case we can do a virtual appointment, no problem. But I think for a lot of you, I was able to resolve some issues by making that document. So if you have questions, all you have to do is send me a message, because those documents take me some time. It's kind of hard for me to do them all together at once. Otherwise, I'd be grading for 3 days, and then I could never get anything else done. So this is the default Lopez-Petrowski constructor. Right there. Now, I think we can do this for fun. So let's try to do our inline stuff, right? Though, obviously, this is a default constructor and this is a default constructor. So, in fact, we don't even have to worry about it. We'll bring it in on the next example. Now, I believe that Lopez will be called first and then Petrowski just because of this ordering. So we'll see that. But then I'll also show you that if we try to initialize origin to be something in here, you know, Polish, Spanish, I get this red line. And it says this is ambiguous because it says I don't know which one you're talking about. And that's true. Now I'm going to comment it out because VS Code is already telling me that it's an error. We would get the same error when we try to compile it. It says this is ambiguous. I don't know what you're talking about. Can anyone tell me in the chat how I can specify which one that I want? We have covered this before. If I wanted to specify either the Petrowski one or the Lopez one, there's a way to do that. And that's kind of how we resolve this thing. But in the meantime, we'll run this code here. Yeah, Peter gets it. The scope resolution operator, that's exactly what we'll use. But let's go ahead and talk about this just real quick. So I made one. Yeah, you got it as well. Nice job. So here we've got this one Lopez-Petrowski going on here, right? Now let's look at this crazy chain of events. So a family constructor is called. Let's look at our diagram here. So the family constructor is called. And then the Lopez constructor is called. Go away, please. So this Lopez constructor is called. But now the compiler says we need a Petrowski object as well. So the family constructor is called again, and then the Petrowski constructor is called again. So we get family Lopez, family Petrowski, and then finally we get the Lopez Petrowski constructor called. And now there's two destructors going on. Why is there two constructors going on? That's a good question. I mean, you can kind of see it here, right? We kind of know why two constructors are being called. Because we got a Piotrowski and we got a Lopez, right? So this multiple inheritance thing is kind of whack. And so if we're ever doing it, we're probably going to be doing some scope resolution stuff. So what I'm going to do here to resolve this is I'm going to say, you know what? This guy has his own origin. Guy has his own origin. And look, now it says this is okay. And it's because it knows that this one has priority over these ones up here. It knows that it has priority. And in here, let's just do it this way instead. We can say this is equal to the Lopez scope resolution operator origin plus, say, a dash, and then plus our Piotrowski origin. And just like that, we've resolved our multiple inheritance issue. So now we'll just talk about the issues with it, and then we'll be moving on. So let's say we got a family construct. We're not even going to do that. Can I zoom in here at all? Okay. Jeez. All right, so we're not even going to do that. We're just going to do a Petrowski. I'm going to turn this down just in case. And then we got a Lopez constructor here. What is this? Size 26? All right, there we go. So in here, this one has its own origin. And this one has its own origin. It's a little small. We can make them red, and we can make them size whatever. We can even center them, and we can even give them some borders. So we can see that pretty good there on the screen. And in fact, we're going to talk about this more next week, about kind of what these things look like in memory. But kind of, the more, this is like, say this is continuous memory. The more things we add, let's say we've got like a first name here or something. And let's say that these guys, the Lopez family, has something else going on. I don't know. Let's say it's like has a history variable or something. These, I'm just pulling these out of my head. There's nothing really too fancy going on here. So these two objects are different in memory. So we've got some strings here and we've got some strings here. So when we combine them in memory for multiple inheritance, is the object a Petrowski Lopez, or is the object a Lopez Petrowski? So you're not going to worry about this too much. This is not on your test anything, but which one comes first in memory? That's kind of an issue that compilers have to deal with. So those are all our multiple inheritance problems. So there's ambiguity, and then there's is class AB or BA. Does that make sense? I hope it does. So that's multiple inheritance. Are there any questions on multiple inheritance before we move on to the best example you've ever seen to wrap up our inheritance discussion in CS202? All right. Excuse me. So I'm gonna add a note here because we're gonna speed through this one, right? Since we've already seen two examples of inheritance, I'm just gonna kind of like code in front of you and talk about it. Yeah, okay, we got a good question here. So, the way I'll say this, I wish I didn't do that, is this kind of has to do more with comparing objects and things like that. So here's a good example of that. So let's say this is located at 0x01. I want these all to be much bigger. So these are hexadecimal addresses, okay? So don't get scared. This is just a number, right? In hexadecimal, I think that's 1. And strings, let's make it better than this. I think strings in general are size 8. So this will be at 0x08. Another string, so this will be at 0x0, or at 16, right? I gotta remember this. I think it's gonna load over, so it's gonna be 1, 0, right? I don't expect... It's okay. So then that's going to be 0, 1. They're all strings. So it's going to be 0, x, 1, 8. And then we're going to add to that, I think it's just going to go 0, x, 2, 0. And then 0, x, 2, 8. I think that's kind of what the memory mapping looks like. Roughly. And so if this class is AB, or the class is BA, and if we say something like, are these two classes equal to each other? Because if you think about it, somewhere in this code, we could write, and I bet this code will compile, family F. I could probably say something like, is F equal to person? Now, it's probably going to tell me that I didn't overload this, which is fine. So we won't get into it. But, you know, a person is, or this object, Lopez Petrowski, is also a family object. You know what I mean? So we should be able to compare them. And when we're talking about memory, it's going to like try to line these up and says, all right, the origin's located here. And then look here, we got a mismatch, right? So I'm not exactly sure. You ask, does it have to do with which constructor is called first or? So let's have some fun with that. I think you reminded me here. But notice we've got a mismatch here, right? In which these objects are the same, you know? They are the same. Except these are lined up at different locations in memory. So whether or not it's AB or BA, it kind of matters in that sense. So let's just do it this way. If we look here, we'll see that it goes Lopez Petrowski. So I think if we swap these, it might switch. Or maybe the compiler just says, I don't care what you think, and I'll do what I want. I'm going to optimize this the best way that I know how. So let's see if that does anything. I'm going to comment this out. So we should see it. I'm not going to clear this, actually. We should see it reverse. Or that's what I'm hoping, right? I have no clue. It does look like it reverses, right? So it looks like C++ here kind of gives you the option to make this either an AB or a BA. So hopefully that answers your question here, which, however we list these, defines which one is called first. And it looks like if we do it this way, it's going to put Petrowski first and then construct these objects. And then it's going to put Lopez next and construct these objects. And then the other way would be this way. And like I said, next week, we'll talk a little bit more about memory addresses and kind of like where these things are stored. These are just names, in fact. They're not stored anywhere. I mean, they are stored somewhere, but not with the objects. All right, so we're gonna put that one to rest. That was a good example. I'm happy about that one. I think we had a good time. So this is going to be our final inheritance example. Now this is based off of an assignment that I made last year. Kind of sad we're not doing it this year, but at least we'll get the example. So this is going to be in-class inheritance. Something like that. I'll probably rename it before I upload it. And we're not going to do these header files. I think you guys understand how the header files work, okay? So even though I'm not going to do it here in this example, you kind of know how that stuff works, and we'll probably see it in future assignments anyway. In fact, you'll see it in assignment 3, which we'll discuss on Thursday. No rush on that. So let me pull up my notes, and I was going to add one thing here, and I say a base class destructor is always called after the derived destructor. Okay, so it's like a little bit backwards, right? It's like a pyramid. It goes base, derived to derived to base. So it's backwards from this one. This is confusing because that's just confusing. So, this example is fun, and I was talking about League of Legends and stuff last time, right? So we're going to kind of do that kind of idea here. And I already typed this out, so we're just going to kind of... I mean, I am going to type it all out in front of you. I think it's important to do that. And just type in the chat if you see anything that you don't know, right, that's going on. But we should all know what's happening here. So I'm going to make a player class. Now, we're going to make these private, I guess, for fun. And you remember what I said players might have? They might have a health. They might have a health bar. They might have a base damage. Now, we're making a game here where no one dies, okay? It's just like UFC or something. They're just going to not be able to fight anymore when their health reaches 0. No one dies. This is a family-friendly environment. When I upload this to YouTube, I have to say it's not for kids. So those are 2 integers. And let's say we've got a character for the player type. So this might be, you know, in this case, we're going to make a ranger and a warrior. Okay, so one uses a bow and the other one uses a sword. So we're going to pretend that this character type is going to be something like a W or an R. Okay. And then we're going to specify what kind of weapon that these characters use. In this case, we've probably got a sword or bow. And I'm going to put some statics in here, okay? So don't get scared. You'll see what these do. We've got a static int, which means there's 1 for all of them. We're going to do a player count. And we're going to have a static int. I'm going to call this the ID count. Now, the ID count is for naming people, okay? We're just going to use that to name our characters. Now, a good practice is as soon as we type in these statics, let's go ahead and initialize them outside of the class. That's what we always do. So we need an int. And then I need my scope resolution, right? Ooh. Control C, player. And then we're going to call the player count. We're going to say that's equal to 0. And we'll copy that. This is going to be the ID count. And let's say our player IDs start at 100. So far, everything should be making sense. Let's move on to our public here. So those are all of our member variables. We've got 2 static member variables. We've got 4 regular member variables. Now, there's quite a few things I'm going to add in here, but in the derived classes, we're not going to have to do much work. So we're just going to kind of huff through it, and let's do it so it looks pretty. So we're going to have a player default constructor. And I like to put my comments. I should do that. So we've got our constructors here. We're also going to have a player constructor that takes parameters that initializes some of these variables. So for the case of this example, we're going to assume that health will be the same for everybody. But I think they'll take in a base damage, a weapon, and a player type. So in this case, we'll pass in a character for the player type. We'll pass in a string for the weapon. And we'll pass in an integer BD for the base damage. Okay, so those are two constructors. We're going to have a destructor because these are so much fun. Because we've got a player count going on, right? So whenever a player despawns, we're probably going to want to decrement that player count. So in this case, we got our destructor here. That's all we need. And now we're going to have 3 member functions. We're going to have 4 member functions. Is that right? No, just 3. The first one we're going to have is a void damage player. Now this is kind of where our inheritance comes in, right? And you'll see it's really cool the way this works. This damage player is going to be called on another player class. So this is going to be the other player. Now immediately, and we'll just come back to it if no one can guess. But does anything look wrong with this? In which, assume this player is going to take some damage, which means that their health is going to decrement. Is there anything wrong with how I've implemented this? And I think I'll just leave it for now. If you have any ideas, you can just throw them in. And if anyone gets it, I will tell you that you're right, but then we'll probably hold off on it anyway for other people to see. So this is going to be receive damage. So the reason this one is this way is that when a player takes damage, I don't want them to drop below 0 health. Did I spell receive? Yeah, I think so. These guys won't be constant member functions because they're going to be altering an object. This one might be constant, but we're not going to test that. And then this one's going to be a static void print player count. That's it. All right, so everything in here should make sense to you. Let me check the chat. Let's see. So we say, is it because all the derived heroes are still players? I like how you're thinking, absolutely. That's not what's wrong with this. What's cool about this is that we can put derived classes in here. Because when we come down here and derive our ranger class and our warrior class, we can just plug them in as a player because it is a relationship that we're talking about. A ranger is a player, and so for sure they'll be able to fit in here. So that's okay. We're going to just leave this as it is, and I'll show you exactly what happens. The first thing that we're going to do is I'm going to implement these kind of down below. Okay, so I think we'll do these. I'm kind of think the best way I want to do this. I think the constructors we can do in line, but the other ones I'll do down below. So I might even just kind of copy paste these. I don't think you need me to. You need to see me type them out. Oh, I missed something. Every player will have their own identifier. Just like your username when you log into Overwatch or whatever. Ha! Sibe! Nice. That's exactly... You are so correct, right? So I'll just say it. This is making a copy, right? This is making a copy of the object. And so are we actually going to damage the other player, or are we going to damage a copy of the player, right? So that's exactly what's going on here. Yeah, you nailed it. Nice job. All right, so look kind of what I got going on here. I just say default base player, their ID spawned. You'll see that. And then I increment the ID count, and I increment the player count. All right, so there's that. The player class will be exactly the same, except there's going to be something else going on here, and I'll type it out in front of your face because I'd like to remind you that. Let's go ahead and initialize these variables the way that we've done it. We'll even do the ID the way that I said. So we'll say ID is going to be initialized to the ID count. We'll say that the health is initialized to 10. My face is probably in the way here. Health is initialized to 10. We'll say the base damage. I'm going to kind of bring this down here because I just want us to be able to see it, you know. The base damage is going to be initialized to, we'll say 1, just 1 damage. What am I talking about here? Health 10, ID count, base damage will be BD. I should have done this for the other constructor. I kind of got way too ahead of myself, but we'll come back to it. The weapon will be initialized to the weapon. And then the player type will be initialized to the player type, the PT. Yeah, if I zoom out, right, this doesn't look too bad. But if I zoom in here because I want you guys to see this resolution, you know, it kind of looks terrible. So I'm kind of just doing it in this disgusting way. Please no judgment. I just want us all to see what's going on here. And I like putting the commas there, but that should work. So the ID gets the ID count. Health is going to be 10. Base damage gets the parameter. The weapon gets the parameter. And the player type gets the parameter. And then we're going to print out the parameter player is constructed. And then we're just going to increment this ID. And we're going to increment this player count. Now I'm going to copy this exactly as it is. And I'm going to place it here. And instead of not having any parameters, notice that they all turned red, right? I'm going to say that this weapon is going to be bare hands, right? Let's assume that the default player has no weapon. They just get some bare hands. Their player type, this is the null character. Okay, that's the null character. I'll put it in a comment. So that just means that this character is nobody. And then the base damage will be 1. Okay? So now that we've done that, I'm going to make it... It's really bugging the heck out of me, so I'm going to fix it. But you can see what's going on there, and as we scroll through, you know that all of these values were initialized, and if you ever have doubts, you can just come onto Web Campus and download this code anyway and take a good zoomed out look at it. And I don't need to do this, right? All right. So we should be good to go. Now in the destructor, we'll go ahead and copy paste some code. The constructors were maybe the most difficult. So I'm just going to say, hey, this player located at this ID, right, from this static count. This guy's going to despawn. And then we subtract our player count. And now these 3 guys I'm going to bring down below main because it's going to get a little involved. And we're just going to kind of move through this. Remember that I need my scope resolution operator if I'm going to be doing this outside of the class. And if this is a static function inside the class, we don't have to include it outside of the class. So the print player count is pretty obvious. It's a cout statement. What does it say? It says there are this many players in the game. So nothing too crazy there. Now, I'll type these ones out for you, except the cout statement. So in the damage player function, we're going to say that, and we're not going to talk about this yet. Not yet. Kind of running out of time here. Maybe I'll mention it. but it probably won't be up in your next assignment. But if it is, I'll be sure to cover it in my comments. So we'll talk about this right now, and we'll put it in the notes. But all this says is player ID deals some base damage to another player, which is the other player ID, using some weapon! Exclamation point. Now, I like to use this here. What is this? We'll put it in the notes since we're talking about inheritance in classes. This, I gotta put it in quotes almost, is a pointer to the current object. Now, what's a pointer? We're not gonna introduce that just yet. I mean, I guess I'll tell you, a pointer is an address. But now we're getting too far into next class. And so I don't want to confuse you too much. But I like to do this here because notice we're working with two players here, right? We're working with this player. And we're working with the other player, right? There's one player that's doing the damage, and then there's one player that's receiving the damage. And so if I type ID just like this, it will work. It'll work, okay? So I won't leave it in the code. This ID is referring to the current object, and the other player ID is obviously referring to the other player. But if I ever want to really, remind ourselves which one is which, I'm saying that this object, this ID, versus the other player ID. So we'll definitely come back to this at a later date. But there, I put it in your head, and now you'll have dreams about it. But I just don't want to confuse you for the upcoming assignment. I don't think you'll have to use it. And I'll verify that. And if you do, I'll fix it. So then, all I'm going to do is I'm going to call this receive damage on the other player. So all I'll do is say other player. I'm going to call this receive damage function. And we're going to pass in, I guess, this base damage, right? But we don't have to use this. But it's the current object's base damage is what we're passing. And that should be that. Now notice I haven't changed anything here, right? So we're gonna see how this code works, and then we'll change it at a later time after we see how it does. And then lastly, we're gonna receive some damage. We're just gonna say x minus equals. You guys know what this one is, right? If you don't, we'll type it out. X is equal to x minus. Whoops. Sorry, everybody. Health is equal to health minus x. That can also be written as health minus equals x. Okay, so they're the same thing. And now here I'll say if health is less than 0, we're going to say, hey, this guy can't be undead. Aaron says, could you call it by reference to change the object instead? That's exactly what we'll do. Yeah, you nailed it. So after I show you how this code works, I'm just going to put that and there, and it's going to fix all of our problems. So it's exactly what we're going to do. That's exactly what we're going to do. Say health is equal to 0. And then I'm going to copy paste a cout statement here because I did plenty of those. And like I said, no one dies here. And here I am doing this thing again. But all I'm saying is player ID can no longer battle. Okay? So that's our player class. And we're pretty much done. But we're going to do our other two classes real quick. And then we're pretty much over with it. Now, the other two classes are going to be very simple. I'm not going to add anything to them besides the constructors and the destructors. So we're going to have a ranger class, a warrior class. So a ranger class, ranger, is going to inherit publicly from the player class. Notice that these are all private, okay? So the ranger class actually, excuse me, does not have access to these member variables. He has no access to these member variables. Now, I don't even think I did anything private. Yeah, so everything in this class will just be public, which is really nice. And we're going to have a Ranger constructor. Now, here's a reminder, right? And this is especially important. I went over this in the multiple inheritance thing, right? Where I tried to call this constructor from within this body. That's not correct, right? So if I want to specify a constructor, I'm going to use the inline method. So we'll put that here in the comments, inline method. I am going to call the player constructor, and one of these, let's see if one will tell me, yep, it takes the player type, it takes a weapon, and a base damage. So let's pretend that the Ranger can do 2 damage. It's going to take a bow, and the player type is R. Okay, just like that. Yep. And then we're just going to do a cout statement. Once again, I'm going to copy paste it. Hope you don't mind. What does it say? It says, oh look, it says that this player ID is private, right? It says that this is private and I can't access it. So let's fix that. Because I at least want access to the identifier. Okay, so that'll fix our life here, right? Look, now it's not red. And that's no longer an issue. And then we'll do our destructor. Are we going to do anything in here? Not particularly. Because up here in this destructor, we already subtract the player count. I don't know why I typed destructor. Guess I'm kind of rushing here, but we've got plenty of time to finish this up. And in this destructor, I'm just going to do one print statement. And it's going to say Ranger player despawned. That's it. And then the warrior class is going to look identical. Someone taught me this last class, so I'm going to try my hand at it. See if I can remember how to do this. I'm literally going to copy paste this Ranger class, and then I'm going to hold Alt. And I'm going to click on this, and this, and this, and I'm going to type warrior. Nice. I don't know why it... Probably because I highlighted there or something. So the Ranger stayed the same. The warrior is now a W, and the warrior will use a sword. And let's say that these guys can do 3 damage instead. And I forgot to add that there, so I almost got it. Okay. So now we can go ahead and do our main stuff. So let's type out just the main, and we'll run our code, and then we'll see that this is an issue. We'll fix it, and we'll see what order our destructors are called in, and then we're done for the day. So, our first thing that we're going to do is we're going to make a Ranger player 1. We're going to make a Warrior player 2. And let me just do some cout statements because I love them, and they really help us determine what's going on with our code. Cout statements are life. So that'll be our start. Then we'll see exactly what happens there. We'll see exactly what happens there. I'm going to put a few more. Here we're going to call player.print. No. I'm going to call this a static function, right? This is a static function, so I can use the scope resolution to access it. I could also do p2.printPlayerCount if I wanted to, but that doesn't really make much sense because it's a static function. So we'll just call it that way. And then we'll call p1.damagePlayer. Now here's where the issue arises, right? But the first thing is this takes a player class. A warrior is a player, right? That's that relationship we're talking about. So we can just pass P2 in there, no problem. There's no issues with that at all. So Rangers can damage Warriors, and Warriors can damage Rangers. And it's all because of this one function up here that can take a player. Take a player object. So that's it. I'm about to run this code. Is there anything confusing that I did? I know that there's kind of a lot of code compared to some of our other examples in here, but really if we zoom out, you know, it's not too scary. I know you can't see that at all. But what? We've got our player class there, we got our ranger and our warrior, and then we got our main. So it's not even that bad. Let's go do some compiling. Let's see that we've got an issue in our code. Let's fix our code, and then let's get on with our day. Bobby's contemplating life. I didn't want to do that one. What did I didn't even load it in here, did I? And I'll rename these so it's not this ridiculous name that I'm talking about. So everything compiled. Now if we run our code, we've got some nice stuff going on here. Right? What is going on there? All right, so let's kind of step through this in our code a little bit. Hey. So we made our ranger here, right? Ranger P1. So if we're looking at that here, we can see that this base player number 100 spawns. And then you can see that the ranger spawns, right? So the default constructor is called first, and then our ranger constructor is called. The next thing we do is we make a warrior. I don't think my face is in the way here, but I can make sure of that. We call our warrior. And so here we've got, look, player 101. We spawn a base player, and then the warrior constructor is called. And then I call print player count. There are 2 players in the game. That is correct. And then I say player 100 deals 2 to the player 101 using a bow. And it says base player 101 despawned. What does that mean? Well, that's exactly our problem that I mentioned, right? There shouldn't be a destructor called there. That doesn't make sense. And in fact, I think a constructor should have been called here. But maybe it just made a flat copy without calling a constructor. But this would be an issue now because if I just take an extra 2 minutes to even print this below, what if this destructor has decremented our player count by 1 when it shouldn't have? I did not mean to open that. So let's just see if that works like that. Then we'll fix our code and then we're done. Yeah, it doesn't make any sense, right? So in fact here, after we damage a player, we've lost 1 player from the game because we called this destructor. And this destructor was only called because we made a copy. We made a copy parameter. So whenever we reach the end of the scope here, right, from this bracket to this bracket, as soon as we pass this bracket, this destructor is called. So we're going to fix that. That's a by reference. That's a by reference. So we add the and there. Notice this should change to 2 players in our game. G++ ./a.out. And it looks like we fixed our problem, right? So just one more time when we're looking at our main code here. The ranger spawns, warrior spawns. There are 2 players in the game. And then we've got player 100 deals 2 to player 101 using a bow. No destructor was called because we changed that to reference. And look, there are 2 players in the game. That's correct. And then at the very end, after we return 0 and we pass this bracket here, notice that the warrior destructor is called first, and then the base player destructor, and then the ranger destructor. So these two are the same, right? These two are the same object, and these two are the same object. And the base destructor is always called after the derived destructor. Derived destructor. And that's that. It's 12:45. Are there any questions about our inheritance examples today? I think this one was kind of fun. I hope that I could keep you engaged a little bit. That's really it for our inheritance notes. So I'll clean these up and I'll upload them to Web Campus. I'll clean up these codes and upload them to Web Campus. Do your homework, please. That's coming up. I think it's due tomorrow night with a late deadline of Wednesday night. I know a lot of you have resolved your problems already. If you haven't, talk to me. Office hours in 15 minutes. I do have one spot in there reserved, so if you don't see me, send me a message. And that's my class for the day. So if you got any questions, type them out. Otherwise, you're free to go. It was great to see you guys in the chat. As always, thank you for chatting in there with me. It makes my day. Makes this more interesting. That's it. I'll call the stream for now. All right, we got a question here. So if we wanted to make a fighting game, we could just use a while loop for their health and have them damage and receive damage from each other. True. In a fighting game, you'll be in an event-based environment where these functions will be tied to like collisions of objects. So you'd have a sword object, and then you'd have a player object, right? So the player object would be this one that we made. We would then make a sword object. And when the sword collides within the environment, it would call damage player. But you could simulate a game using a while loop. Or you could just, you know, if you wanted to, right, we could say while int 10, you know, int 0. I'll let you do that on your own. But does that make sense? Yeah, you could simulate a fighting game in a terminal code if you wanted. If you ever have the chance, Red Rosenrot, take, well, just keep an eye out for it. If you ever see a game development class, if you take that, it won't be too hard, and you'll kind of get this thing. Yeah, you make a weapon class. And then in that Unity development class, you'll use a free software called Unity. You'll actually just be able to make the little sprites in the game, and it's like a physics engine. And whenever the sword collides with something, then you would call some functions that you wrote. Yeah. So I'll catch you guys next class. Come to office hours if you need. I'm going to take my 11-minute break here, make some tea. Adios.